Okay, this is lesson 3 in the moles and stoichiometry unit. In today's lesson, we're going to learn how to calculate between moles and grams, and we're going to reinforce the mole concept. The application of the mole. This has to do with math and chemistry. We need to convert from grams to moles and vice versa for this class. Now, remember in the beginning of the year when we did dimensional analysis, you needed to know conversion factors, like 12 inches is a foot, and 3 feet are a yard, and 2.54 centimeters equals 1 inch. Well, we're going to use conversion factors here also, but they have to do with conversion factors that are found explicitly in chemistry. On the back of our reference table in Table T, you will see a formula that says moles equals given mass, GM, divided by gram formula mass, which is GFM. So basically, in this lesson, you have to know how to solve for moles, which is straightforward, because if you use this formula, you're just plugging and chugging. Put your given mass here, your gram formula mass, divide, you got your answer. But the second part of the lesson, you need to know how to find the given mass when you're given the moles, and you can calculate the GFM. So this makes this equation a little bit more difficult to solve. Well, what you need to know is that there are 3 conversion factors for math of chemistry regarding moles. The first is 1 mole equals the gram formula mass. So remember, the gram formula mass is the mass in grams. So if I say that I have 1 mole of magnesium, then 1 mole equals 24.305 grams. 1 mole also equals 6.02 times 10 to the 23rd units. Now this can be atoms, molecules, things. These are all equivalents. And 1 mole equals 22.4 liters if the substance is a gas. So I'm going to put if a gas down here. So these are 3 unit conversion factors that we can use in this unit. So as I said, when converting from grams to moles, you would just use the mole calculations formula as is. We don't have to do anything dimensional analysis, rearranging the equation, because it's straightforward. So let's look at the first example. How many moles are in 4.75 grams of sodium hydroxide? Let's not forget given, find, formula, solve. So I'm given 4.75 grams of sodium hydroxide, and I need to find moles of NaOH. That's what I don't know. I have a formula, moles equals given mass over GFM. I don't have to memorize this, it's on table T. But in order to calculate this problem, I need the GFM of NaOH. And that's what I'm going to do right here. So I have 1 sodium with a mass of 22.98977. I have 1 oxygen with a mass of 15.9994. And I have 1 hydrogen with a mass of 1.00794. So those would just come over here. I'm not going to rewrite them because there's only 1 of each. And then I'm going to sum those, and I get 39.99711. And that would be grams, because they want the GFM. Remember, formula mass is in AMUs, and GFM is in grams. Next, plug the given value and the GFM into the mole calculations. So my given mass was 4.75 grams, and sorry, this is grams per mole. And my GFM is 39.99711 grams per mole. And what happens is my grams cancel, and when I divide this out, I'm left with 0.11875. Now this has 3 sig figs, so I'm going to probably just use 3 sig figs. Look to my right, greater than 5, 0.119 moles of NaOH, and that's my answer. So we're building on a skill that we learned in the last lesson, which is calculating the GFM. Let's do a couple practice problems. How many moles are in 39 grams of LiF? 39 grams of LiF. I don't know moles of LiF. That's what I'm finding. And I've got moles equals given mass over GFM. So I need to find the GFM of LiF. Well, I know I have 1 Li, and that's got a mass of 6.941, and I have 1 F, and that has a mass of 18.9984. I need the sum of that, which is 25.9394 grams. So my moles equals my given mass, 39 grams, over my GFM, 25.9394 grams per mole. My grams cancel, and when I divide, I'm left with 1.5 moles of LiF, and that is my answer. Okay, should be getting the hang of this now. What is the number of moles of potassium chloride present in 148 grams? Well, here I didn't give you the formula. So you know potassium is K, has a +1 charge, chlorine is Cl with a -1 charge, so these combine at 1 to 1, so the formula is simply KCl. So we have 148 grams of KCl. We don't know the moles of KCl, that's what I'm trying to find. My formula is moles equals given mass over GFM, and I need to find the GFM of KCl in order to use the formula. So I have 1 K, and K has a mass of 39.0983, and I have 1 Cl, and that has a mass of 35.453. I have to sum those, and I get 74.5513. So my moles equals my given mass, 148 grams, divided by my GFM, which is 74.5513 grams per mole. Grams cancel, and when I divide, I get 1.985. However, 148 only has 3 sig figs, so I'm probably just going to use 3 sig figs. So this would then be 1.99 grams per mole of KCl. Okay. You should really pause me and try to do this next one on your own. How many moles are in 168 grams of KOH? So I have 168 grams of KOH. I don't know my moles of KOH. My formula. So I have to find the GFM of KOH. Well, we just found out in the last problem that K was 39.0983, and O, so this is K, O is 15.9994, and H is 1.00794. We have one of each, so we need the sum of that. We get 56 0.10564. So my moles equals 168 grams divided by 56.10564 grams per mole. My grams cancel. Do the math on that and you get 2.994. Again, 168 is 3, so I'm going to go to 3 sig figs, so this is simply 2.99 moles of KOH. Okay, so in all of these problems we have calculated moles. We went from grams, given mass, so this is the given mass in all of these. We went from given mass to moles. Now we're going to reverse that and we're going to go from moles to given mass. So when we convert from moles to grams, from table T, you would still use the mole calculation formula, but now you have to rearrange it since you're solving for. Now there's actually 3 ways to do this problem, and I'm going to show you all 3 ways, because you're not simply solving for the variable on the left of the equal sign. So our regular formula is moles equals given mass divided by GFM. So in the first method, when you solve, you can simply put a 1 here, and then you could cross multiply and divide. That's the first method. I really don't like setting up a proportion because if you get a more complex formula, you guys don't know how to handle it. In the second method, you can rearrange the formula, which is what they did here above, and I'll show you how they did that. The original formula is moles equals given mass over GFM, but I want to solve for given mass. So remember, we do the reverse order of operations. So if this was divided by GFM, we are going to multiply both sides of the equation by GFM. These now cancel, and what you're left with is given mass equals GFM times moles, which is what they have here. Mass of the sample, given mass, equals, they just put the moles first, times GFM. That's rearranging the formula to solve for a different unknown. The third method, which is my favorite and the preferred method, especially if you plan on taking my upper level chemistry class, is using dimensional analysis. Oh boy, you guys thought you'd never hear that word again from the beginning of the year. Wrong. Okay, so what we do there is we just start with what we're given. So in dimensional analysis, we're going to be going from moles to grams. So what we need to do is pull out one of our conversion factors. 1 mole equals the GFM. I told you 3 conversion factors, but this is the one that we need for this. And we're going to be starting with moles of X. They're going to give us moles of X. And you know that 1 mole of X is equal to the GFM of X. So moles are going to cancel, and it's just going to be this times this. So here's all 3 methods that you can use. I'm going to do the first problem using all 3 methods, and then after that I'm just going to use dimensional analysis. We're missing part of the problem here. So they want us to calculate the grams of H2SO4. if I'm starting with .5 moles. So again, what am I given? 2.5 moles of H2SO4. I have to find the given mass of H2SO4. That's my question mark. I'm going to solve it using one of the three methods, either dimensional analysis, proportion, or rearranged formula, because I'm doing this first one three-way. So the first thing that I need to do is find the GFM of H2SO4. So I have two H's, 1.00794, sulfur is 32.065, and oxygen is 15.5994. So let's extend these out. 2 times the mass of hydrogen is going to give me 2.0158. We've only got one sulfur, and we've got 4 oxygens, 63.9976. So the sum of that is 98.07848, and that's grams per mole. All right, so this is the rearranged formula one that we did. So this is simply going to be 2.5 moles times 98.07848. And that's going to equal 245.1962. So we're just going to leave this as 245 grams. I would probably go to the tenths place, but in this case this only had 2 sig figs, so I'm not going to mess around with it. Technically our answer should only have 2. This should have probably been 2.50, which was an oversight in the way the problem was built. So this was actually the second method. Okay, the first method was simply using moles equals given mass over GFM. And what that would look like is 2.5 equals X over 98.07848. And this is grams per mole, and this is grams. So these are going to cancel. And what you do is you put a 1 here. And then you've got 1 times X, which is X. So X equals, and then you've got this times this, which is going to give you the 245.1962, which is approximately 245 grams. And then the third method was dimensional analysis. And how we do that is we just start with what we're given, 2.5 grams, and we know that, 2.5 moles. I wrote the wrong thing over here too. This is moles. This should have been moles. Change that. And then it was the moles that canceled because we were finding grams. I forgot what we were finding. There we go. So we know that 1 mole equals the GFM, which is 245.1962 grams. And then moles and moles cancel, and it's simply this times this, which is 245 grams. No matter what way I do it, 3 different methods, I get the same answer. So let's do some practice problems. What is the mass of 4.5 moles of KOH? So 4.5 moles KOH is my given. I need to find GM of KOH, given mass, and I'm going to solve it by dimensional analysis, and I'm going to use the conversion factor 1 mole equals the GFM. So I need the GFM of KOH. So I have 1K, 1O, 1H. And we just did this in another problem. And K was 39.0983. Oxygen was 15.9994. Hydrogen was 1.00794. We need the sum of that, and we get 56.10564, and that's grams. So, dimensional analysis. I'm starting with 4.5 moles of KOH. And I know my conversion factor, 1 mole equals the GFM. Well, if I want moles to cancel, 1 mole has to be on the bottom. So 1 mole equals the GFM, 56.10564 grams. So moles cancel. And I am going to get 4.5 times 56.10564 equals 252 grams of KOH. You get 252.47538 grams. And we're just going to go to the tens place, so we're going to make it, no, we'll just, yeah, go to the tens place, but this is less than 5, so we'll just round down 252 grams of KOH. All right. All right, I'll get it together here. What is the mass of 0.05 grams of CuSO4? So we've got 0.50 grams of CuSO4. We don't know the moles. We don't know the mass. Given mass of CuSO4 is a question mark. We're going to use dimensional analysis, and we're going to use 1 mole equals the GFM. We need to find the GFM of CuSO4. So we've got 1 Cu, 1 S, and we've got 4 O's. So 4 times 15.9994. Sulfur is 32.065. And copper is, I believe, 63. 63.546. So we have to extend this out. This is going to be 63.9976, 32.065, and 63.546. We need the sum of that. 159.6086 grams. So let's do our dimensional analysis. 0.50 moles of CuSO4. And you know that 1 mole has a mass of 159.6086 grams. Moles cancel. So 0.5 times 159, and you get an answer of 79.8043. So we'll just leave it at 79.8 grams of CuSO4. Now I don't care what method you're using. I'm not solving each problem for 3 different methods. You can go back to the 3 methods and see which one you like the best. Alright, next one I tried to trick you. What is the mass of 1.5 moles of nitrogen gas? How do we write nitrogen gas? Please don't tell me that it's just N, because it's part of Brinkelhoff, so it must be written as N2. So 1.5 moles of N2 is what we're starting with. We don't know the given mass of N2. We're going to solve it using dimensional analysis and a conversion factor. But we do need the GFM of N2. Fairly easy, it's 2 times 14.0067, which gives us a mass of 28.0134 grams. So we start with our dimensional analysis, 1.5 moles of N2. We need moles on the bottom so that moles cancel. So 1 mole equals the GFM, 28.0134 grams. Moles cancels. So obviously, if we're going to multiply this out, we're going to get 42.0201 grams. We can leave that as 42 grams of N2. And that's my answer. And apparently you have one last one, which isn't written here, but you're given I believe this is number 4, 0.75 moles of SO2, and you need to find the given mass. So we need the GFM of SO2. Sulfur is 32.065, and we have oxygen, we have 2 times 15.9994. So 32.065 plus 48 point, no, this is going to be 31.9988 plus the 32.065 gives us 64.0638 grams. Starting with our moles, we know that 1 mole equals the GFM. Moles cancel. So we just multiply the two together and we get 48.04785. So this is 48 grams of SO2. And that's it. Have a great day. Make sure that you are meticulous in your labeling. Make sure that you're writing down what you're given, what you're finding, what method, formula or method, and then solve. And make sure you show your work.